NASA reveals Pluto and Neptune may have oceans beneath icy surface. In the constant search for the extraterrestrial life, NASA, the U.S. space agency, study proposes that some icy worlds in our external cosmic system may have liquid water shores beneath the surface. According to the new NASA research, the heat produced by the gravitational pull of the moons created from massive collisions could increase the lifetimes of liquid water oceans beneath the surface of vast icy worlds in our outer solar system. This dramatically extends the number of locations where alien life might be discovered, since liquid water is required to support known forms of life, and scientists expect there are dozens of these worlds. Prabal Saxena of NASA's Goddard Space Flight Center in Greenbelt, head author of the investigation published in Icarus on November 24, said that these objects need to be considered as potential reservoirs of water and life. If our research is correct, we now may have more places in our solar system that own some of the crucial elements of alien life. These distant worlds are discovered beyond the orbit of Neptune and include Pluto and its moons. They are identified as trans-Neptunian objects and are far too cold to have liquid water on their outsides, where temperatures are less than 350 degrees below zero Fahrenheit. However, there is data that some may have layers of liquid water underneath their icy crusts. In addition to bulk densities that are related to other bodies suspected to have subsurface oceans, an investigation of the light reflected from some TNOs unveils signatures of crystalline water ice and ammonia hydrates. At the shallow surface temperatures on these objects, water ice takes a disorganized, amorphous form instead of the regularly ordered crystals typical in hotter areas, such as snowflakes on Earth. Also, space radiation converts crystalline water ice to the amorphous structure and breaks down ammonia hydrates, so they are not supposed to survive long on TNO surfaces. This proposes that both compounds may have come from an internal liquid water layer that ejected to the surface. This is known as cryovolcanism. Study co-author Wade Henning of NASA's Goddard Space Flight Center in Greenbelt, Maryland, said that we observed that tidal heating could be a tipping point that may have shielded oceans of liquid water underneath the surface of large TNOs like Pluto and Eris to the current day. The conclusion greatly extends the number of places where extraterrestrial life might be found, since liquid water is required to support known forms of life, and cosmologists consider there are dozens of these worlds. The lead author of the research, Prabal Saxena of NASA, stated that these objects need to be considered as possible repositories of water and life. Mr. Saxena continued that if our research is correct, we now may have more places in our solar system that hold some of the critical elements of the alien life. The research team used the equations for tidal heating and calculated its contribution to the heat budget for a wide variety of observed and open TNO moon systems, involving the Eris Dysnomia system. Eris is second most significant of the currently identified TNOs after Pluto. The investigators determined that the gravitational interaction with the Moon can produce enough heat inside a TNO to significantly increase the lifetime of a subsurface ocean. The NASA research team would also like to improve and use even more accurate models of tidal heating and TNO interiors to learn how long tidal heating can increase the lifetime of a liquid water ocean and how the orbit of a moon emerges as tidal heating dissipates energy. The crew would further like to explore at what point a liquid water ocean forms, whether it forms almost instantly or if it requires a notable buildup of heat first.